Hello, my dear students. This is P. Venkateshwarlu, PGT Physics, Tinandar Public School. Okay, we know that already the revision classes starts. Okay, already one class is completed. Okay, understand, my children? How many classes completed? Yes. Okay, so once again I will explaining all definitions. Along this video I will send one soft copy for the definitions, and please thorough these definitions, and I send some questions how the question will form. Okay, so I think you don't know how the question form in +1 and +2. Okay, so due to this I will send some questions along with this video. Okay, my dear children. So coming to introduction of motion in a straight line. Okay, so first motion. What is motion? A body is said to be motion which displacement or distance, the position of the particle will changes continuously with respect to time and surrounding material. With respect to time and surrounding. And rest. What is rest, medicine? Yes. Rest means a body said to be rest. The body position will not change with respect to time and surrounding medicine. Okay. So this motion and rest are relative. Relative means so by observing a person on a bus. Okay. Beside a person standing in bus stop. The thinking of sitting in bus, the person observed the passenger which is beside the bus also, which is in motion. Means, so while traveling in a bus, your friend is waiting for another bus at bus station or bus stop. Okay, that person also look like, so you are thinking like, so which is assumed like which is moving. Okay, so another example, while traveling in any train or bus or vehicle, trees are moving back. Okay, so this we can say relative. This we can say this phenomenon we can say relative. Okay, motion and rest are relative, my dear children. So coming to types of motion. Types of motion means 1D motion, 2D motion, 3D motion. Okay, a particle moves along straight line, so we can say 1D motion, motion is straight line. A particle moves x and y axis, so we can say this is motion in a plane or 2-dimension motion. A particle moves x, y, z axis. So this type of motion we can say motion in 3D. 3-dimension motion. 3-dimension motion, my dear children. Okay, so next frame of reference. Frame of reference. So frame of reference is the reference point where the observer can observe. Okay, see here, you sitting on the bench and seeing physics video. Okay, so I am moving left and right. Okay, so you are sitting, your position where you can sit and where you can see. Okay, that we can say frame of reference. This frame of reference is two types, inertial and non-inertial frames. Inertial and non-inertial frame of reference. Inertial frame of reference means the frame of reference which obeys the Newton laws of motion. Okay, so which moves uniform velocity or rest. Non-inertial frame of reference we can say accelerated frame of reference. In this, Newton laws cannot obey. So then displacement, distance, my dear children, displacement, distance. Displacement. The shortest path between initial and final is called displacement. Okay, displacement, it may 0, it may positive, it may negative. Okay, my dear children, distance. The distance between the actual path between final and the initial initial position. The actual path between initial and final position we can say distance. Okay, so displacement it is vector, distance it is a scalar quantity. So coming to speed, my children, coming to speed. Speed is defined as the ratio of distance traveled in unit time. Speed, distance by time. Distance by time, my children. Understand, my children? Speed is defined as the rate of change of distance of. It is the ratio of distance traveled by a particle in a unit time. Like so, it is scalar quantity. It is scalar quantity. So its SI unit meter per second, and its dimension formula m power 0 l power 1 t power minus 1. So it is a which quantity, Nana? It is which quantity? Yes, scalar quantity. So next, average speed. Nana. So average speed, it is defined as average speed. Average speed means total distance, total time taken. Okay, total distance, the ratio of total distance to the time taken. Total distance by total time taken is called average speed. Okay, so understand average speed. So based on the average speed, we can have number of problems. Okay, understand number of problems. So formula average speed. Okay, for two velocities, v1 and v2 velocities, VAVG is equal to v1 v2 divided by v1 v2 medicine. v1 plus v2. Very important one, my children. Okay, so this derivation is very important. Okay, consider a particle which covers half of the distance with v1 velocity and remaining half of the distance covered with v2 velocity. Okay, in this case, the average velocity or the average speed v is equal to 2v1 v2 divided by v1 plus v2. So if we can represent any speed with a direction, we can say velocity. Okay, with the magnitude, we can say that is speed, my children. Okay, so derivation, how we can derive means, okay, the total distance is half of the distance covered with v1 speed with t1 time. So remaining half of the distance covered with by the particle v2 velocity to cover s2 displacement or distance in t1 time. Okay, so we know that average speed means what now? Yes, total distance by total time taken. Okay, understand total distance by total time taken. Here in this case, we know that v1 by t1 is equal to s1 by t1 is equal to v1. Then t1 is equal to s1 by t1 is equal to s1 divided by v1. s1 divided by v1. Understand, my children? Understand? Now here in this case, s1 plus s2 divided by s1 by v1 plus s2 by v2. Okay, understand? So in this case, you have to write s1 plus s2 what? s1 plus s2 what? No? Yes. s1 plus s2 means yes. Because s1 plus s2 is equal to s. Or s1 is equal to s by 2. s2 is equal to s by 2. Okay, understand? And here, because of this relation, we have to s by v1 plus s by 2 v1, s by 2 v2. Okay, so s divided by s by 2 1 by v1 plus 1 by v2. Okay, s gets cancelled. Rearrange this 2 divided by 1 by v1 plus 1 by v2. Rearrange this, my children. By rearranging this, we can get 2 v1 v2 divided by v1 plus v2. v1 plus v2. Very, very important one. Based on this problem, so guarantee based on this formula, we can have problems. Okay. Okay, children, I think this one you have doubt. I think 2 divided by 1 by v1 plus 1 by v2. 2 divided by 1 by v1 plus 1 by v2. LCM v1 v2 v1 v2. Okay, so here v2 come plus here v1. Rearrange this 2 v1 v2 divided by v1 plus v2. Understand? So this is the key of this relation. Okay, understand, my children? Coming to average speed of a particle which covers 1/3 equal path covered with v1 and remaining v2 and last v3 velocity, my children. Yes, that average speed which is equal to 3 v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. Okay, very, very important relation, my children. Very, very important. Understand, my children? Very, very important one. Next, instantaneous speed. Instantaneous speed Instantaneous speed, which is defined as the speed of the particle at particular instant of time. Okay, so which is given as in the limit formula of v instant, which is equal to limit delta t tends to 0 delta x by delta t. Understand, my children? This you can write ds by dt or dx by dt, where ds is called distance. Okay, this instantaneous speed, average speed having same dimension formula with the velocity, my children. Next, velocity, which is defined as the rate of change of displacement. Displacement by time. Is called velocity. SI unit is meter per second. Dimension formula m power 0 m power 1 t power minus 1, like speed. Okay, so velocity we can have two types, uniform and non-uniform velocity. Equal displacement covering equal interval of time, so we can say uniform. And non-uniform means an object said to be variable velocity or non-uniform velocity. Unequal displacement covers in equal interval of time. Next, average velocity. Average velocity is defined as the total displacement by total time taken. My children. Instantaneous velocity. Coming to instantaneous velocity. Instantaneous velocity is defined as the velocity of a particle at any instant of time, my children. Okay, Okay, next relative velocity. Relative velocity, my children. So relative velocity is defined as the comparison of velocities is called relative velocity. Okay, understand? Understand, my children? Yes. Relative velocity of one object with respect to another object is the time rate change the relative position of one object with respect to another object, my children. Okay, so relative velocity of two bodies. Okay, so consider two persons A and B, which are moving with different velocities VA, VB. Okay, understand? So the relative velocity means VAB is equal to VA minus VB, or VBA is equal to VB minus VA. The comparison of velocities is called relative velocity. Relative velocity, my dear children. Okay, so and acceleration. Acceleration. So acceleration is defined as the rate of change of velocity, my dear children. The rate of change of velocity is called acceleration. So acceleration, the SI unit of acceleration is meter per second. The SI unit of acceleration is meter per second. So this acceleration also uniform, non-uniform acceleration. Okay, so uniform acceleration, if the object moving with the uniform acceleration, it means that change in velocity equal for equal interval of time. Okay, change in velocity equal interval of time is called uniform acceleration. Coming to non-uniform. Okay, non-uniform velocity is defined as the change of velocity. The change of velocity with respect to time is differ. Okay, understand? Sometime the speed, the velocity of the body will changes continuously. This type of velocity we can say non-uniform velocity. Next, acceleration. Average acceleration. The average acceleration means the sum of the total velocity to the total time taken by a particle. Like next, instantaneous acceleration. My dear children. Yes, instantaneous acceleration is defined as the acceleration of the particle at particular instant of time. My dear children. So next, we can have graphs. Okay, graphs. So from the previous videos you learn graphs. Okay, so and I will give some homework, so which is very important one. Okay, so we have a displacement or distance time graph, velocity time graph, acceleration time graph, my dear children. Okay, and freely falling body also very important one. Freely falling body. Okay, my dear children. So I will give you homework. So go through it, my dear children. Okay. So based on the motion in one dimension means motion in a straight line. Okay. Based on the derivations, we can have some problems. Okay. Understand, my dear children? Yes. So along with I will explain some. I will send to you some soft copy to read. Okay. So if you can have any doubts, ask me offline or online call. Okay, my dear children. So this formulas very important one. Okay. So regularly you can follow that homework. Okay. Can have some internal marks in the exams, and if you can have doubts, you attend Zoom live or you call offline call.